Bem-vindos ao programa do Algarve à Lapónia. Esta semana vamos conhecer dois projetos em duas regiões distintas de Malta que receberam fundos europeus da União Europeia.
It has been a dry year, hasn't it?
It's very dry. I never seen air like this in my life. When I was a kid, it was full of water and every year less.
How do you manage to get water for your culture?
There is a well and I get from there.
What's that statue over there?
We call it the Salvatore.
You are working under the Salvatore protection.
Yes. When I see him there and he protect me.
Do you ask him for rain?
I ask him and I pray for rain, but
Mas em plena primavera, as orações de Fábio não são atendidas durante mais do que 5 minutos naquele que é o segundo país europeu onde menos água cai.
Malta is semi-arid. It's not an arid country, but it is semi-arid. So generally we get about half a meter of rainfall every year. This year is special. It's special in terms of that we are not close to half the annual rainfall. So this year we're about 200 millimeters of rainfall, and summer is nearly with us. So the question is, how much more do we have left till we get to summer? When we speak about climate change, this rainfall has really dictated how people build their houses to collect its rainfall.
É o mais pequeno Estado da União Europeia e também o mais densamente povoado. Só para termos uma ideia, vivem no arquipélago de Malta mais de 500 mil pessoas, a ocupar uma área que é inferior à do concelho de Coimbra. Isto para não falar dos imensos turistas que visitam estas 3 ilhas do Mediterrâneo durante praticamente todo o ano. A questão é, num arquipélago que não tem águas superficiais, ou seja, onde não há rios nem há lagos, como dar de beber a todas estas pessoas? A resposta está, obviamente, nas vizinhanças da ilha.
É na ilha de Gozo que fica instalada a mais recente e eficiente central de desalinização da água do mar em Malta.
Here in Malta, we have 4 reverse osmosis plants that in total they produce 70% of the potable water demand of our islands, 70,000 cubic meters per day. We have 3 in Malta and one on this smaller island, the one that you see behind me, and it produces about 9,000 cubic meters per day of potable water. The water that we produce is for potable use, which is not just for drinking, it's just for the general use of the customers.
Inaugurada em 2021, a central de Gozo é gerida pela Water Services Corporation, a entidade pública responsável pela gestão da água em Malta, e venceu em 2023 o galardão mundial Energy Global Award. Custou mais de 12 milhões e 800 mil euros, dos quais 11 milhões suportados por fundos europeus, e usa um sistema de osmose inversa para transformar água do mar em água potável, 3 vezes mais cara do que as águas subterrâneas.
It is an automated plant, which means that we don't have people here around the clock. Reverse osmosis technology, it's a membrane separation process. It's a very simple process where you have a membrane, a semi-permeable membrane, that allows water to pass through it, but it doesn't allow salt molecules to pass through it. In this process, we just reverse the natural process of osmosis by pressurizing the salt water through the membrane, and only fresh water will pass through, but the salt molecules will stay on the first side of the membrane. So in that way we can separate at least 40% of the seawater and convert it into fresh water. It costs a lot of energy because we have to pressurize water at high pressure, which is about 60 to 65 bar. It is different than if you had a groundwater system where you just take water out of the ground at low pressure. So reverse osmosis costs about 3 times as much as we produce from groundwater. And by that I mean that we produce water here at about 3.5 kilowatts per cubic meter.
Para além dos custos energéticos, retirar o sal da água implica outro desafio ambiental.
What does happen to the salt?
It is in solution. So it is water, seawater that has been concentrated further, and now it is very much concentrated and we have to throw it back into the sea. But before we do that, we take energy out of it. So since we are operating at a very high pressure, we use that reject energy to convert about 60% of our low pressure water to high pressure water by an energy recovery device that uses this brine reject stream. So it is a very efficient system where before throwing the brine into the sea, you recover that energy by pressurizing the seawater up to 60 bar. The plant behind me, there's a pipe under the sea, and it is about 360 meters out. So in the end of the pipe there's a diffuser, so we make sure that the reject that's going into the sea is being diffused according to the permit that we have been given by our environmental authority, and we are ensuring that there's no impact on the marine environment.
Enquanto a água do mar dessalinizada segue para consumo humano, há uma outra fonte que abastece a pequena e média agricultura praticada em Malta.
This is an urban wastewater treatment plant where we receive approximately 10,000 cubic meters per day. It is an activated sludge treatment plant. The treated effluent goes to a step we call the polishing plant. The first step is the ultrafiltration. The treated effluent from the sewage treatment plant passes from the membranes of the ultrafiltration, and it removes approximately 99% of any impurities that are still in the water. The second step is the reverse osmosis. The reverse osmosis membrane removes the salinity from the water. Salinity of the treated effluent is approximately 3 to 4,000 microsiemens, and we lower that down to the region of 3 to 400 microsiemens, which is the equivalent of drinking water. The next step is the advanced oxidation phase. Here we use ultraviolet lamps to kill and remove anything left in the water. Then this water is distributed to our farmers, anywhere between 3,000 to 4,000 cubic meters per day of polished water. For example, in the winter periods, it is a little bit less, because obviously the need for water is less in winter than in summer.
O projeto New Water integra um conjunto de ações de eficiência hídrica em Malta, orçamentado em quase 90 milhões de euros. 85% do valor vem do Fundo de Coesão da União Europeia e serviu também para testar a qualidade da nova água que será consumida indiretamente pelos malteses.
What do you have on those two glasses?
So, this is water from the sewage treatment plant. It has passed all the stages of the sewage treatment plant. And this is after it has passed from the polishing plant. This water has passed through all the stages of the polishing plant, from the ultrafiltration, the reverse osmosis, and the advanced oxidation. Look at the difference.
So this one is ready to go to agriculture.
This one is ready to go to our farmers. It is very safe. Our farmers grow everything from strawberries to potatoes, lettuce, cabbages, cauliflower, everything.
Not just trees.
No, not just trees. It's good for vegetables you eat Directly, yes.
I suppose there were a lot of studies before you reached that conclusion.
Yes, of course. There are a certain set of parameters imposed on the systems, so anything more is not safe. But less than these parameters, the water is considered safe for agricultural use.
Our groundwater has been like the most important source of fresh water. These changing rainfall patterns are of concern because groundwater, where does it come from? It comes from the rain. Malta is an island surrounded by the sea. So basically you have seawater which is underlying, which is underneath our fresh water and on the sides, surrounding it. So there's this very delicate balance, which the amount of fresh water coming from the rain through recharge, the water which is infiltrating through the ground, and abstraction, this amount of water which you're pumping out. So there's this balance, a very delicate balance. If you abstract too much, if you take too much, the groundwater becomes saltier. So there are certain aquifers which are, the balance is positive, but some of the bigger aquifers, the most important ones, are actually in a negative balance.
Em Malta, as únicas reservas naturais de água doce estão todas debaixo da terra e a sua quantidade depende, logicamente, da chuva que cai, que, como sabemos, não é muita. Mas manter a qualidade química destas águas subterrâneas pode também ser um desafio. Tudo depende das atividades que são praticadas à superfície da terra. E, neste caso, esta área verde que agora estamos a ver era, até há bem pouco tempo, uma lixeira a céu aberto. Deixou de o ser, mas o lixo continua cá. A diferença é que já não está a contaminar os aquíferos.
Under our foot, several meters down, there's 2 billion kilograms of waste. Feel safe, don't worry.
Okay.
The fact that you haven't smelled it or didn't have any idea that it was here, that's a good sign. It is called Wit Folia, which in Maltese it means that it was a valley. So there was also a water course which has been lost.
Esta é uma de 3 lixeiras em Malta convertida em zona verde. Do orçamento total de 4,5 milhões de euros para pagar o projeto, os fundos europeus pagaram 3,5 milhões.
In the past, Malta decided that they'll use this scenic site, as you can see behind me, as a designated landfill, and unfortunately, again, there wasn't any protection to the surrounding environment. What do I mean by protection? Nowadays, the directive asks us to use technologies to engineer a landfill to avoid its impact on the surrounds. And one of the main concerns were fires that might come from the digestion of waste. You have also the issue of stability and the environmental issues. And after that study, we had a risk mitigation measure and we had a plan of how to intervene. There was a purging exercise to remove any surface gases and avoid accumulation. And then thereof, we used the directive to cap the landfill. What does that mean? It means that we put what I call as a raincoat over it. That raincoat avoids the gases to emit from the landfill and the water to percolate inwards, because if you get water in the waste, it will collect the different contaminants, creates leachates, and obviously contaminates the sea behind us and also the water table. So after we have kept it, we started putting what we call geocells, because you have the slopes. They are like they create pockets which stabilize soil in its place the soil, agricultural soil, and planted circa 43,000 trees and shrubs. We are happy today, as you can see, that this has thrived and has attracted even more biodiversity.
A bacia do Mediterrâneo está a aquecer a um ritmo 20% mais rápido do que a média mundial. A pequena Malta sozinha pouco pode fazer para travar as alterações climáticas, mas com o apoio da União Europeia tem feito os possíveis para adaptar-se a elas. Com a imagem de João Junça, Duarte Baltazar, RTP em Malta.
Não se esqueça de nos seguir nas redes sociais em RTP Europa. Eu sou o Vítor Hugo Mendes, a RTP na Lapónia. Até para a semana.